Greatest common factor. Factors shared by two or more whole numbers are called common factors. The greatest of the common factors is called the greatest common factor, or GCF. So, for example, if we want to know the greatest common factor of 24 and 36, we have to list all the factors for 24, which are 1, 2, 3, 4, 6, 8, 12, and 24. And the factors for 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. So, as you can see, I wrote in orange the ones that are the same, that means which are the common factors. And the greatest one of them is 12. So that means that the greatest common factor of 24 and 36 is 12. Finding the greatest common factor. To find the greatest common factor, we're gonna use three methods. The first one is the list of factors, which is the one we previously used in the previous problem. So here, to find the greatest common factor of 16 and 24, we have to list all the factors for 16. Remember, you can always do all the combinations for the number, and that means all those numbers are the factors of 16. So factors of 16 are 1, 2, 4, 8, and 16. And now factors for 24, it'll be 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So the factors are 1, 2, 3, 4, 6, 8, 12, and 24. So as you can see, the common ones are the orange, and the greatest one of the commons is 8. So the greatest common factor of 16 and 24 is 8. Now method 2 is using prime factorization. So to compare them, we have to find the prime factorization. We can use the factor tree. So prime factorization of 12 will be 2 times 6, 2's prime, and 6 is 2 times 3. So I circle the prime numbers. And then for 24, it's 2 times 12, I circle the 2. 12 is 2 times 6, I circle the 2. And 6 is 2 times 3, so I circle 2 and 3. And now for 32, prime factorization is 2 times 16, circle 2. 16 is 2 times 8, circle 2. 8 is 2 times 4, circle 2, and 4 is 2 times 2, and I circle both. So once you have the prime factorization, you're gonna write them. You can either write them in the expanded form, like I did in here. So the prime factorization for 12 is 2 times 2 times 3. For 24 is 2 times 2 times 2 times 3. And for 32 is 2 times 2 times 2 times 2 times 2. And you compare them, and you're gonna circle the factors that repeat in the three numbers. So as you can see, the 2 repeats 2 times in the three numbers. That means the greatest common factor is 2 times 2, which is 4. Now, that is if you use the expanded form. If you use the short form, which is the one using exponent, this one will be 2 to the second power times 3. For 24 is 2 to the third power times 3. And for 32 is 2 to the fifth power. And then to compare them, you're gonna use only the factors that repeat in the three numbers. Which is the factor that repeat in the three numbers? The 2. And then you're gonna use the smallest exponent, because the smallest exponent is included inside this and this. So 2 to the second power is the same as 2 times 2, which is 4. So as you can see, You can write it in the short form or the expanded form. You're going to get the same answer. So the greatest common factor of 12, 24, and 32 is 4. Now the method 3 is using the ladder diagram. If you remember, the ladder diagram was like a table where you get the prime numbers of a number, but here you can get the prime factorization of more than one numbers. In this case, we have 3 numbers. So you write them like in columns, and then you're gonna divide them by the same prime number. So by which prime number we can divide 12, 18, and 60? The smallest one is 2. They are all divisible by 2. So 12 divided by 2, the answer will be 6. 18 divided by 2, the answer is 9. And 60 divided by 2, the answer is 30. So now we have 6, 9, and 30. By which number we can divide again? The 3 numbers by 3. They are all divisible by 3. So 6 divided by 2, the answer is 2. 9 divided by 3, the answer is 3. And 30 divided by 3, the answer is 10. Okay. If I cannot divide anymore, that means I finish, and that my greatest common factor is the multiplication of 2 times 3. So that would be 6. So it's the same I did here. So as you can see, the greatest common factor is 2 times 3, that is 6. So the greatest common factor of 12, 18, and 60 is 6. Now problem solving application. There are 12 boys and 18 girls in Mr. Reed's science class. The students must form lab groups. Each group must have the same number of boys and girls. What is the greatest number of groups Mr. Reed can make? So here they're just asking us for the greatest common factor of 12 boys. So we have boys and we have girls. We have 12 boys and 18 girls. So if I want to use the ladder diagram, I divide them by 2. They are both divisible by 2, so this one will be 6. This one will be 9. I can divide them again by 3. This one will be 2, and this one will be 3. I cannot divide anymore. That means my greatest common factor is 6. Now this method will be very useful if they ask you how many boys and girls in each group. So there are going to be 6 groups with 2 boys and 3 girls in each group. You can also use any other method you want. In this case, I use also the list of factors. So all the factors of 12 are 1, 2, 3, 4, 6, and 12. And all the factors of 18 are 1, 2, 3, 6, 9, and 18. So as you can see, the greatest common is 6, which is the same as we get with the ladder diagram. So the greatest number of groups we can have is 6, and if they ask you how many of each inside each group, that would be 2 boys and 3 girls. So this will be all for this lesson. If you have any question, you can send me a message. Don't forget you have to do process in each problem, and in the word problems you can choose any method you want. My advice is if they ask you how many of each inside each group, it's the best method is the ladder diagram. Okay, so take care. Any questions, send me a message. Bye.